We will be working on adding, subtracting, multiplying fractions in this warm-up. Let's go ahead and get started. So for number one, we're going to be subtracting these mixed numbers. Remember, the first step is to determine a common denominator. And we don't have one. Many of you already figured out the common denominator would be 8. The least common denominator is 8. But if you didn't, if you couldn't figure it out, you would just use the ladder method. And you know that 4 can go into both of them. And 4 goes into 4 once, it goes into 8 twice, and then you draw a giant L for least common denominator, which means we multiply these three numbers. 4 times 1, which is 4, and then times 2, which is 8. And so our least common denominator is going to be 8. So let's rewrite these fractions. 3/4 is going to be something over 8, and 2 and 1/8, or sorry, 2 and 1/8 is going to be something over 1/8. Well, yeah, that still stays 1/8 because you're gonna, multiply by 1. And 4 times what equals 2? Well, if you just go look at that, cross them, you can see what you multiply them by. So 4 will be multiplied by 2, which means I multiply the top by 2 as well. So 3 times 2 is 6. Now we have 5 and 6/8 minus 2 and 1/8. Now we just do some subtraction. 6 minus 1, well, that equals 5. 5 over what? 5/8. And then we have, we're not done yet because we have the whole number still, 5 minus 2. Well, 5 minus 2 is 3. And it is a proper fraction. It can't be reduced. This is our answer, 3 and 5/8. Let's take a look at number 2. Again, what we want to do is we want to find the least common multiple. And, rather than working through the whole thing, we know the least common denominator, or least common multiple, is going to be 8. The only difference with this problem is we're going to be adding, so let's go ahead and rewrite this. Can you multiply this by 2 and this by 2? This is going to get you 6/8. And then down here, this is still 1 over 8. So we're adding 6/8 plus 1/8. Well, that is going to be 7/8. Instead of subtracting 5 and 2, you are adding them up, and you get 7 and 7/8. You can't reduce this. It is a proper fraction, so that's our answer. Let's go ahead and take a look at number 3 and 4, 5, and should say 6, but it says 5 and 5. All right, number 3. 6 and 1/4 times 2 and 2/5. For this one, we do not need a least common denominator or a least common multiple. We just multiply as is, except that we can't multiply with whole numbers. So we do need to convert these. So we need to change them into improper fractions. So to do that, we multiply these two, and then we add. You add afterwards. So 6 times 4, that is going to be 24. And 24 plus 1, well, that is going to be 25. 25 over 4. Now, it's actually going to be easier to multiply when you write them across from each other, like this, rather than on top of each other, because basically you just multiply straight across. All right. Now we have 5 and 2/5. We start off by multiplying these two, and 5 times 2 is 10. And then we add these two afterwards. So 10 plus 2, well, that is 12. And it's still going to be over 5. So now we multiply straight across. But I always think it's a good idea to do some cross-canceling first, or some reducing. So when we cross-cancel, we just have to cross that fraction bar. 25 and 4 can't be reduced, but 25 and 5 can be. So we cross that out because 5 goes into both of them. 5 goes into 5 once, 5 goes into 25 5 times. Now, 5 and 4, no. 4 and 12, yes. We can divide both of them by 4, so I'm crossing that out. 4 goes into 4 once, and it goes into 12 3 times. So, can I reduce any more? I cannot. So, we just multiply straight across. 5 times 3. 5 times 3 is 15. And 1 times 1 is 1. Now, 15 over 1 is not a proper fraction. 15 divided by 1 is 15, so that's going to be our answer. Let's do the last 3 problems, number 4, 5, and should say 6. All right, so for the following word problems, please set up how to solve them. So we don't actually need you to work the problems out. We just want you guys to set this up to show us whether you add, subtract, or multiply. Jerry walked 2.5 miles, and Maria walked 3 3/4 miles. How much farther did Maria walk? We are comparing how much farther someone walked, and when we're comparing how much more, or we're asking what's the difference between how far Jerry and Maria walked. Well, a difference means subtraction. So we are going to subtract 3 3/4. That's how far Maria walked. And we're going to subtract 2.5, which is how far Jerry walked. And that's going to be our answer. We're going to look at number 5. Anne was stacking boxes in the garage. The distance between the floor and the ceiling is 12 1/4 feet. And she put down a box that is 3.5 feet tall. How much more space does she have between the top of the box and the ceiling? This seems kind of complicated, but I could draw it. Imagine that she has a garage. The distance between the floor and the ceiling is gonna be 12 1/4 foot. And she put a box down that's 3.5. So this box right here, it's 3.5 feet. And it's now asking us, what is the distance from the top of the box? How much more space does she have between the top of the box and the ceiling, which is this space right here? Well, it's the whole thing minus this thing. Oh, so that's just subtraction. 12 1/4 minus 3 1/2. And that is the answer we're looking for. That's the setup. Finally, Josh rides his bike 5 days a week. If he rode his bike 10 1/5 miles each time, how many miles has he traveled in a week? Well, he rides it 5 days a week, and he rides it 10 1/5 miles each time. How much would he travel each week? Well, we could add 10 1/5 5 times, or we can just do 10 1/5 times 5. So you could do that, or you can do 10 1/5 plus 10 1/5 plus 10 1/5 plus 10 1/5 plus 10 1/5. But even saying that was exhausting, so I would not recommend adding it 5 times. It just would take a while. So that is how you solve this warm-up. Hope that wasn't too bad for you.